So this problem here, f of x equals 2 the square root of x plus 2 plus 1. The xy chart, we got to get perfect squares under the radical. -2, -1, 2, and 7 accomplish perfect squares on the radical. When you plug them in, -2 plus 2 is 0, the square root of 0 is 0. 0 times 2 plus 1 is 1. -1 plus 2 is 1, the square root of 1 is 1. 1 times 2 is 2, plus 1 is 3. 2 plus 2 is 4, the square root of 4 is 2. 2 times 2 is 4, plus 1 is 5. 7 plus 2 is 9, the square root of 9 is 3. 3 times 2 is 6, plus 1 is 7. When I graph those points, -2, 1, -1, 3, 2, 5, 7. This is my graph. My domain, as I read the graph, is x has to be greater than or equal to -2, or we can write that -2 bracketed parenthesis around the infinity. For the range, that represents our y's. Y has got to be greater than or equal to 1, so I bracket the 1 and I put a parenthesis around the infinity. It's a vertical stretch by a factor of 2. And is I have the 2 outside the radical. The shift is going to be left 2, up 1 from the origin, from 0, 0. So we have another square root. We got to create perfect squares. 3 does that. 4 does that. 7 does that, and 12 does that. So the 12 will fly off the graph a little bit. That's okay. We'll do the best we can with it. We guesstimate a bit there. 3 minus 3 is 0. The square root of 0 is 0 times -1/3 is 0 plus 1. So 3, 1 is kind of my initial point. 4 minus 3 is 1. The square root of 1 is 1. 1 times -1/3 is -1/3 plus 1. That's 2/3. 7 minus 3 is 4. The square root of 4 is 2. 2 times -1/3 is -2/3. -2/3 plus 1 is 1/3. And finally, 12 minus 3 is 9. Square root of 9 is 3. 3 times -1/3 is -1. Plus 1, we get 0. So, 3, 1. 4, 2/3. 7, 1/3. And then 12 is on the x-axis. So that's what our graph's going to look like. It's working downward. Our domain, my x is greater than or equal to 3. Or I can write it as bracket 3 to infinity. My range, y is less than or equal to 1. So that becomes -infinity with a parenthesis and a 1 with a bracket. That's your domain and range. Because the number in front of the radical is less than 1, greater than -1. It's a fraction with a 1 numerator. Our vertical, it's going to be shrink by a factor of 1/3. And because the negative is outside the radical, we reflect over the x-axis. So that is your transformation. A vertical shrink by a factor of 1/3, a reflection over the x-axis, and where are we going from that original point, from the origin? We're going right 3, in this case up 1 as well. So that's the complete transformation. Now with cube roots, we have the f of x equals the cube root of x plus 1 minus 2. Now with cube roots, I'm not looking for 0, 1, 4, and 9 anymore. Now I'm looking for 0, 1, 8, and 27. I'm looking for perfect cubes. So I'm going to start with my -1. That gives me my 0, and I got to go in both directions. -2 and -9. I'm going 0 and 7. That creates perfect cubes. Remember, a perfect cube can be negative. A perfect square is not going to be negative. Perfect cube can be negative. Negative 9 plus 1 is negative 8. The cube root of negative 8 is negative 2. Minus 2, negative 4. Negative 2 plus 1 is negative 1. The cube root of negative 1 is negative 1. Negative 1 minus 2 is negative 3. Negative 1 plus 1 is 0. 0 minus 2, negative 2. 0 plus 1 is 1. The cube root of 1 is 1. 1 minus 2 is 1. I'm sorry, 1 minus 2 is negative 1, excuse me. And then 7 plus 1 is 8. Cube root of 8 is 2. 2 minus 2 is 0. Your cube root graph will look much more like this. Negative 9, 1, 1, 2, 3. Negative 9, negative 4. Negative 2, negative 3. Negative 1, negative 2. 0, negative 1. 7, 0. This is the shape of a cube root. The domain and range of a cube root is pretty easy. It's always going to be, in our case here, negative infinity to infinity, and the range will also be negative infinity to infinity because the cube root can be negative. There's no negative in front of the radical, and there's no negative in front of the x. So there's no reflection. There's no number in front of the radical. There's no vertical shift or stretch. No vertical stretch or shrink. So the only transformation is we're going left 1. What makes that radical equal to 0? And we're going down 2. That is the only transformation here. Y or f of x, actually. F of x equals the cube root of negative 4x plus 4. Once again, we've got to create perfect cubes. I'm looking for negative 8, negative 1, 0, 1, and 8. Negative 8 under here comes with a negative 2, or comes with a, shouldn't say a negative 8 comes under there. Ends up being a positive 8. So negative 2 creates the positive 8. Cube root of 8 is 2. 2 plus 4 is 6. The next number I'm going to use is negative 1/4, because that creates my 1, another perfect cube. Negative 1/4 times negative 4 is 1. The cube root of 1 is 1. 1 plus 4 is 5. When you plug the 0 in for x, you get 4. That's pretty straightforward. When I plug 1/4 in for x, I get negative 1. The cube root of negative 1 is negative 1. And negative 1 plus 4 is 3. And then finally, if I plug a 2 in, I get a negative 8. Cube root of negative 8 is negative 2 plus 4 is 2. So, negative 2, 1, 2, 3, 4, 5, 6. Negative 1/4, 5 is like that. 0, 4. 1/4, 3. And then 2, 2. And that's what your graph looks like. Once again, it's a cube root. The domain, negative infinity to infinity. The range, negative infinity to infinity. Our shifts, we're just going up 4. Now, here's the deal. You have a negative 4 in front of the x in the radical. That means its horizontal shrink by a factor of 1/4. You always take the reciprocal of the number in front of x when you're doing horizontal shrink and stretch. So, for example, if I had a 1/2 in front of the x, that would be horizontal stretch by 2. If I had a 1/4 in front of the x, I'd be horizontal stretch by 4. I don't have that. I have a 4. I have a 4 in front of the x. Therefore, it's horizontal shrink. We take the reciprocal of it. And because it's a negative in front of the x, we reflect over the y-axis. Okay, that needs to be remembered. That's on the other sheet of Sayala gave you.